We could do this one. It looks like it's set up for you. It's very tempting to do it with mesh analysis, but it turns out it's actually pretty easy to do with nodal analysis, because this one is one that we could use a supernode. So someone had asked about a supernode on Monday. This is when you would use a supernode, when you have the two voltages that are separated by a voltage source. And so what this tells us is that V1 is V2 plus 10 angle 0. Or the other way of writing it, V1 minus V2 equals 10 angle 0. So the positive side minus the negative side equals the label on the voltage. And then I can do a nodal analysis equation. So starting from V1, I have V1 over 10, and then going down, plus V1 over J20. And then because it's a supernode, I can keep going with the same equation and go over to V2 plus V2 over 15 plus V2 over minus J5 equals 0. And then I can replace my V1s with V2 plus 10, and it's angle 0, so I can just say V2 plus 10 over 10 plus V2 over J20 plus V2 over 15 plus V2 over minus J5 equals 0. And then here's how I'm going to do this. I'll write this as V2 over 10 plus 10 over 10 plus V2 over J20 plus V2 over 15 minus V2 over J5, and then I'll take the equals 0. I'll take the 10 over 10 to the other side, so I have negative 1, and then I'll factor V2 out of everything else. So then I have 1 over 10 plus 1 over J20 plus 1 over 15 minus 1 over J5. So 1 over 10 plus 1 over J20 plus 1 over 15 minus 1 over J5 equals I'll get it in polar. .224 angle 41 angle 41.987 equals negative 1. So V2 equals negative 1 divided by 0.244 angle 41.987. anybody see a mistake that I made?
So it's supposed to be V2 plus 10 over J20.
Yes, it was. So this was supposed to be, so this side was supposed to be minus 1 minus 10 over J20. Yeah.
In the beginning, you said it was with the supernode, it was V1 minus V2 equals 10 equals 0. Were you not supposed to set that equal to like, the equation that you set up? Like you said it would equal to 0. I thought it would equal to 10 equals 0. Or might I just misunderstand the supernode?
I did it a different, I might have done it a different way than what you had done it. So I'll explain in a minute after I make sure that I have the right answer. Still not the right answer. Let's see. What am I doing wrong? Okay, so getting back to your question, the way I do a supernode is you have two equations. One equation is your relationship between the two nodes, which I have right here. The other equation is your nodal equation that you get from summing up all the currents coming out of the nodes. And I do know that I have that correct. So I do know that I have that correct. It's in my solution where I messed up somewhere. So I have V2 over 10 plus 10 over 10 plus V2 over J20 plus 10 over J20 plus V2 over 15 plus V2 over minus J5 equals 0. So that's all correct. So this So this side is 1.11 angle 153.4. And the other side was
so funny when I said that. I was like, bro, that's so bad. I was like, what chip can I send? That's gonna be like, yeah, I'm not gonna. And I found out, I was like, that's so funny.
We're going to get their reading class today.
That was funny.
I saw that on the other that's the one.
Point 224. Oh, okay. This is where I copied this. I'm terrible about this. It's 0.224, and I put 0.244. So 0.224.
I have a question.
Yes.
Where did that minus 10 over G20 come from?
Let me finish this. Let me see if I can finally get the right answer, and then I'll explain.
I guess it was. I got it.
Yeah.
Yeah. I think it's because this is B2 plus 10 and that numbers. Come on. It's right here. And then we're not going to have B2 involved. Oh, the B2.
Acting like they do, but they're not doing anything.
Because the V2 is.
Oh, good.
That is the right answer. Okay. So V2 is 4.95, angle 111. Okay, so where did it come from? It was the mistake.
I just copied it down.
Oh, well, no, it was a mistake. I made it earlier. It was a mistake I made. I forgot when I plugged in up here, I forgot the plus 10 right there. And so this should have had a plus 10 over J20, and then I had to subtract it over on that side.
Just because it didn't have V2 in the, because like it didn't have V2 in the thing, so whenever you went to factor out V2, you just had to move it over.
That's right. I needed to move everything that didn't have V2 to the other side. All of this was just solving for V2. This was all just complex algebra, which
And
is...
then like,
Is that
or
10
whatever's
over?
inside the
J20.
parentheses
Yes,
below that, is that just like, that's in pretty much rectangular form, and then you just convert that to polar form?
correct. So I just did this addition on the calculator and then converted it to polar. And then I converted this to polar. And then I did and that gave me 4.9 angle 111 degrees. Now, V1 is 10 more than that, and so to add 10 to that, it's a lot easier to have it in rectangular. And so in rectangular, it was negative 1.78 plus J 4.6.
It's V2 times 0.244.
Hold on. 4.6. negative 1.8. Okay, what was the question?
He was asking if that was 0.224.
It's 0.224.
And then what's, okay. So like, what do you do once you have that? You just have to, like, I guess if you have a complex or calculator that does complex numbers.
By the way, this calculator costs $20. I mean, it does not break the bank.
We just bought one before we did.
It's $20. It's, on Amazon. Yeah. And it's, that one is okay. So you got an 89?
Yeah.
That one, this one will do stuff for
I'm
you.
gonna like convert it back and forth.
Yeah, so let's see. I'm gonna have to get my 89 and remind myself, but I will show you how. And this one's worth having. Keep holding on to that.
It does
You're there.
I have
That-
an
that
80
one-
middle school. I have an 83. Will that do it?
No.
It won't.
No. It'll do some stuff for you, but it's not gonna do all of this, like where I'm mixing polar with rectangular. 83, 84 can't do that. I think I already posted a video on using the 84, which will be the same as the 83 with, I'll check and see if I did. It's
I
like,
think you did.
I think I did. I haven't done the 89 because, but the 89 is way cool and it does a lot of stuff. So it's worth having. I had,
Whatever that
so
is.
then I did V2 equals 1.11 angle 153.14 over 0.224 angle 41.987. And I just typed both of those into the calculator. Or you can do 1.11 divided by 0.224 to get this part, and you can do 153.14 minus 41.97 to get that part.
And where did the 1.11? That's just.
This was
Oh, that's
this
just-
converted to polar.
It's the minus 1 over 10 and J20.
It's minus 1 minus 10 over J20. Yep. Which you should be able to. You should be able to see this and say, oh, that's minus 1 over J2, which is the same as 1 plus J.5.
So like, what was the thing that he was talking about where like, depending on what quadrant it's in, you have to add a subtract
Yep.
80?
Yep. That's if you have to do it by hand, which I never do. Let's say I had minus 4.2 minus J662, no, minus J6.5. And I want to convert that to polar. Now, the way I would convert that to polar is I would say I do that, and I do second complex, and I would do convert to polar, and I would get 7. Oh, actually, this one works. Let me get one that doesn't work. Oh no, it doesn't. This one gives me 7.7 angle negative 122. So 7.7 angle negative 122. Now, if I do it by hand, I get the square root of 4.2 squared plus 6.5 squared, and that will give me 7.7. And then the inverse tangent of negative 6.5 over negative 4.2. And if I do the inverse tangent of negative 6.5 divided by negative 4.2, I get 57.13, which you see is not the right answer. And the reason why is if I look at this number right here, it's negative 4.2 in the real axis, negative 6.5 in the imaginary axis. It's right here. But inverse tangent only gives me angles between here and here. It's only going to give me angles between plus 90 and minus 90. And so if it's going to be in the third quadrant, I have to take the angle that it gives me and subtract 180 degrees.
If it's in the third quadrant.
If it's in the third quadrant. If it's in the second quadrant, it will give me a negative number, and I have to add 180 degrees.
Are you posting this problem?
I think I am. It appears to be recording. Yeah.
So
Okay.
if it's in the second quadrant, we add 180. If it's in the third
Yeah.
quadrant, we subtract.
So A plus JB, the magnitude is square root of A squared plus B squared. Angle is inverse tangent of B over A. If complex number is in the third quadrant, subtract 180 degrees from calculator answer. If complex number is in second quadrant, add 180 degrees to calculator answer. Oh. Oh, and then just going back, when I changed that back to rectangular, then I can say that V1 is V2 plus 10, and V2 in rectangular was minus 1.8 plus J 4.6 plus 10, which is 8.2 plus J 4.6.
So like the super node thing that you were doing is pretty much just the two equations that you got saying like V1 is equal to V2 plus 10 at 0 degrees. That's the super nodes
Yep,
mathematically.
yep. So this gives me V1 equals 9.4 angle 29.6 degrees. So what the supernode did for me is when you do nodal analysis, you get a system of equations. And this made one of the equations V1 minus V2 is 10, or V1 equals V2 plus 10. The other equation I got by doing the nodal analysis, but doing it on both V1 and V2 at the same time.
And we could find V1 by just plugging V2 into that same, the
Yes, that's what I just did right here, was I added 10 to V2, but to add 10 easily, it's better to have it in rectangular form.
because we can't.
You can't
by
add
hand.
with phasors by hand. Okay, so I would like to